Nice. Okay, cool. Remember, you can always do more if we may not have time to start our homework in class today. If we do, it might be just the last few minutes. Remember, it's Monday and Tuesday are review, and the test 8.3 to 8.6 is Wednesday, okay? So we are continuing to use truth, and we are going to be finding the area of triangles using trig to find out the base of the height of our triangles. Some of the triangles are going to be right triangles. Some of the triangles are not going to be right triangles. So a little recap. These are the formulas. Well, this is the formula. And you can write it as 1/2 times the base times the height, or the base times the height. Oh, okay. Sorry, you could have had next time you come and call me, and I'll do it, okay? Okay, cool. Hold on, I don't see it yet. I think normally the session just ends on its own. Okay, you should be good now. Says the same thing? Oh, wait, no. What period are you? Okay, so the formula for the area of a triangle is 1/2 times the base times the height. Another way to think of it is the base times height divided by 2. Remember, those are the same thing, multiplying by 1/2 and dividing by 2. If you've got a fraction that we're using for our base and our height, then I would use 1/2 times. And you can use that all the time if you like. I always kind of default to this one, but that's up to you. Now, remember, just as a reminder, the base and height are the legs of the right triangle, or the legs are the sides that make the right angle. So you're adding this to your notes, Adine. What if it's not a right triangle? It's not a right triangle, what are we going to do? Not a right triangle, any of the three sides could be the base. Because if it's not a right triangle, we can pick a side as a base and then draw the altitude to find the height. Like when you learned about parallelograms, find the area of parallelograms. For some of them, the base and the height were interchangeable. So if it's not a right triangle, we pick a side as a base, then draw the altitude to find the height. If you've forgotten what the altitude is a segment drawn from the vertex opposite that side we want. Well, an altitude is just a segment drawn from a vertex to the opposite side of the triangle at a perpendicular 90-degree angle, right? But we're going to pick a base, and then we're going to draw the altitude that is perpendicular to that base. Y'all caught up? So we're going to look at this example. We've got the area, they're asking us to find the area of the given triangle. Round your answer to the nearest tenth. Do not round any intermediate computations. So this is what we went over yesterday real quick, so it wouldn't be the first time you saw it. So this is a right triangle, so the base and height are the legs of the right triangle. We've been referring to these legs as opposite and adjacent, but really it's the opposite leg and the adjacent leg, right? So this side on the right triangle across from the right angle is the hypotenuse. So if we're looking at this acute angle, now we want to label the opposite leg and the adjacent leg, right? So opposite and adjacent. Now, we don't really need opposite and adjacent if we're just using the formula for the area of a triangle, except we only have one length. One of these is the base and one of these is the height, right? So we are going to have to use a trig ratio to find the other length. So if we use 14 as the base, and we can use either one of the base. I could have swapped those as far as, I already did that. So we could have swapped, we could have used, made this side our base and this side our height. But we're looking for the other leg, the length of the other leg. It doesn't matter which letter we call them. Okay? So before we can find the area of a triangle, we have to find out the height of this triangle. So we're going to use a trig ratio. We've said that this leg that we're looking for is the opposite leg. I'm going to label that H. I'd like for you to label that one H as well. This one is the hypotenuse, so the variable we're using for the height, that's the variable in the formula, is H. So, which trig ratio can we use to find the length of side H? Which trig ratio can we use? So we have opposite and adjacent, yes, it's tangent. The tangent of our 33-degree angle is equal to the opposite, which is the height of our triangle, over the base, which is the adjacent. So opposite over adjacent. How do we solve this equation? How do we solve for H, I should say? Very good. Multiply both sides by 14. And if they asked us to round and did not tell us we can't round our intermediate computation, then we would plug this into our calculator, right? So times 14 times 14. Now we're simplifying here. So now we know our height is 14 times the tangent of a 33-degree angle. So because they don't want us to round in the intermediate computations, we're not going to put that in our calculator yet. We're going to plug that expression in for H in one of these formulas. So the base is, so the area of the triangle is equal to the base, which is 14, times the height, which is 14 times tangent of 33 degrees, divided by 2. So we're going to put that in our calculator. You can just go straight across the top, then the fraction bars divide by 2. I do want everybody to practice doing it. Make sure your calculator's on degrees, not radians. It says RAD, turn it off and turn it back on, and it should pop up to DEG. What you get? Hi, Brielle. You're still working on it? What'd you get, Maria? Okay. Give you another second. You got it, Gabrielle? What's it say? 63.6. Okay, so we're going to the 10th place. Yep, 63.64, which means it's going to round to 63.6. They don't give us a unit here, so if we had to label it, we would label it square units. Right? If they label it meters, we label it square meters. If they label it inches, we would label our answer as square inches, and so on. Any questions? Okay, moving on. Just please find the area of the given triangle, round your answer to the nearest tenth, and do not round any intermediate computations. So is this a right triangle? Yes. So we know, we see the little right angle indicator, so now we know that this is a right triangle. So one of these is the base, and one of these is the height. I just went through, anytime we're looking for the base or the height, I made that the one they gave us, the base. So in this case, we're going to call the side that is 14 units along the base. The side across from the right angle is the hypotenuse. So we know there's an acute angle at 52 degrees. We need to see which trig ratio we want to use, so we're going to label our side. The hypotenuse, we don't have a value there. We don't really need it, but we're kind of trying to make sure. A lot of you guys are still having trouble labeling adjacent and opposite, and I want to make sure we go through a process. So if we start at this acute angle and look straight across, now we know that that is the opposite leg. And the one that's left has to be the adjacent leg. So we're going to call the adjacent leg, which we're looking for, we're going to label that as H, and that's our base. So opposite and adjacent, what's our trig ratio? Tangent. So the tangent of this 52-degree angle is equal to the opposite over the adjacent. So the opposite is 14, and the adjacent is H. What do we do if we have a variable in the denominator? What did we say we could do on these? Yeah, we can swap. So we can swap tangent of 52 and H, switch to the positions. Algebraically, if you do it, that's just what happens, so we're going to take that shortcut. We're not going to put this in our calculator because they asked us not to run intermediate computations, so that looks a little bit weird. So because this is a fraction, I'm going to use the fraction version of the formula. I don't know if it makes any more sense to you guys, but we would be putting a fraction in a fraction, and I know that always freaks kids out. All right, well, we don't have to do that. So the base is 14. So it starts with 1/2 times our base times 14 divided by the tangent of 52 degrees. So how are we going to put that in our calculator? I'm going to let you guys get it written down, and we're all going to walk you through how to put it in your calculator. It's just going to be, so remember, a fraction is just a division problem. So it's going to be 1 divided by 2 times 14 times 14 divided by 52 tangent equals. So working left to right, top to bottom. 1 divided by 2 times 14 divided by 52 tangent. Don't forget the equal sign. And we're rounding to the 10th place. What'd you get, Thomas?
76.6.
Perfect. Anybody get something different? Okay. And it's square units because they don't have it labeled. You just got it already? Okay, so clear it out 2 times. Now try it. 1 divided by 2. You can do a fraction, 1 ABC 2. But you can't use the ABC button with the tangent at the bottom. So you can do the fraction there. 2 times 14 times 14 divided by 52 tangent equals. Okay? Okay. So yeah, you can use the fraction button. But as we learned, you can't use the fraction button if you got 4 digits on top or bottom, and you can't use the fraction button with any of the trig ratios. You could, I don't think you can use it in the denominator or numerator. Okay? All right. So, what if it's not a right triangle? You don't have to write anything. I'm going to wait and make sure you all get caught up, and then we're just going to put our pencils down and look at the board. Okay? So this is not in your notes. We're just going to talk about it a little bit. So if it's not a triangle, which side is the base, and what's the height? So any of the three sides of this triangle, we could consider the base, and we could draw an altitude to any of them to find the height. Okay? So if it's not a right triangle, there's not a right angle in here, we're going to pick the base. So we could pick 7 or 11. Technically, we could pick this side, but for our purposes, we need some numbers, right? So we're going to pick the ones with numbers. So if we pick 7, that could be a base. We could pick 11, that could be a base. To determine that height, once you designate one of these sides of this triangle as your base, then you draw the altitude perpendicular to that. Right? So the altitude, by definition, is perpendicular. So you draw the altitude from the opposite vertex. So what does that mean? Well, if I choose this base, right? Now I've got to draw the altitude from that. The problem is, in this obtuse triangle in particular, I can't get an altitude that goes from there, right? So, but what we can do is we can extend this side and then create a right triangle on the outside. So now this is the base, and this would be our height. Okay? So now we've got this right triangle. We know the length of the hypotenuse. If we know the length of, or the measure of this angle, now we've got two numbers, we can use a trig ratio. Do you know how we could find that angle measure there? Xavier, any idea how we find that angle measure there? What do you think, Elizabeth? Do you know? Tell me what you think, and then tell me what he thinks. Let's see if you guys are thinking the same things. Be brave. It's okay to be wrong. You don't have to tell me what it is. Tell me how to find it. We'll let Kelly with his idea. I think you're right. Why do you think 180 minus 140? Yes. So we have created a second angle here. This angle and this angle all together create that straight angle, right? It's 180 degrees. So if this angle is 40 degrees, then we subtract this one. If this is 140, then this is 40. So now we have an acute angle and a right triangle. We have this side length. So we can find one of the other side lengths. Make sense, Xavier? So what if we decide that the base is 7? Well, we're going to start at that base and extend that line and then draw from this vertex. So then we're still starting at a vertex here to create our altitude. It's just on the outside, but it's got to be perpendicular to the line that contains this side, right? So now we have another right triangle, and it's still going to be a 40-degree angle here. So it's still 180 minus 40, all right? So I just wanted to throw that out there before we started actually putting numbers in to find the area. Okay, so this is what we're going to be doing. If they're these obtuse triangles, we've got this, they're long and skinny like this, we're going to draw our altitude on the outside. So this says the area of a triangle given SAS. Miss Riley made these notes, so at first I'm like, that's the congruency theorem. Do we need that? But they're just saying that they're given a side included angle side, right? That's all they're saying. We know the measure 9 meters. We know the measure 13 meters. Together, those sides create that 49-degree angle. So it's a side, angle, and a side. That's all that's saying. All right? So if we have this triangle, we're going to do the same thing as we did. We are going to pick a side for our base. Then we're going to draw the altitude to create a right triangle. So there are two different ways to do it because there's two different sides labeled. We just need to use one with a label. So it's got the link. So I designated the side link, the side with the link 13 meters as the base. So I drew the altitude. And I don't really like that I drew that not with the dotted line because it's not part of the triangle, right? It's representing the length there. So this altitude is perpendicular to this base. And we don't know where it lands on this. It's not a bisector, right? So, but all we need to know is we're trying to create a right triangle, because if we have a right triangle, then we can use that to use the trig ratios to find our height. So far, so good? Yes? All right, great. So this is going to be our height. This is going to be our base. This is our unknown. In relation to our acute angle, well, it doesn't have to be in relation to our acute angle. This is the hypotenuse no matter what, because it's across from the right angle. But is H, is that the opposite or the adjacent side from our acute angle? Opposite. Very good. So you start at the angle and just draw yourself a line across. That makes it the opposite. If it's not the opposite and it's not the hypotenuse, then we know it's the adjacent, right? We don't need the adjacent, so I'm not going to label it. So now, if we know our height is the opposite, on the other side length we're going to use is the hypotenuse, what trig ratio are we going to use? Morgan? Sine, yep. No sinning in geometry, it's sine, yep. So it's going to be the sine of the 49-degree angle. It's going to be equal to what? Daria? What's our ratio? What's our fraction going to be here that it's equal to? Okay, so what's our memory trick? What do we say? Go ahead, Demarcy. SOHCAHTOA. So you said sine, right, Daria? So, how do we spell so in that memory tool? So what's coming first, the opposite or the hypotenuse? Say it again. It is going to be h over 9, opposite over the hypotenuse. So now we've got to get our height, our h by itself. We've been doing this a lot, so I'm going to not really belabor that. We're multiplying both sides by 9. Once again, well, it's not exactly. Let's look at our directions here. We're simplifying here, multiplying both sides by 9, and then these 9s are going to simplify to isolate our height. This says carry your intermediate computations to at least 4 decimal places. Well, instead of rounding to 4 decimal places, we're just going to keep it in the same expression we were using in the right for the other ones. So rather than put it on our calculator and round, let's just leave it like that. Right? Let's just leave it as the height is equal to 9 times the sine of the 49-degree angle. And now we're going to plug into our formula. So if the base is 13 and this is the height, what's going to be in the numerator of our fraction? Tori, what are we going to put in the top? Just 9? Okay, so we're plugging into the area formula now. So what is the base? What is the B? And what's the height? You want to help her, Thomas? What's the height? Isn't there an H right there? Isn't that where we're solving for? Vivian, what's the height? Yeah, that's the height. So the base is 13, and the height is 9 times the sine of the 49-degree angle. The area of a triangle formula tells us to divide by 2. So I put it in parentheses because it's more of a grouping that as our H. But really, you don't need the parentheses here because you can multiply in any order, right? I can multiply 3 times 2 and get 6, or I can multiply 2 times 3 and get 6. All of these are factors in that numerator. Everything's getting multiplied, right? So it's just 13 times 9 times the sine of 49, but on our calculator, remember that's 49 sine button. And then the fraction, we just divide by 2. Everyone should be trying it on their calculator now. Just write it down, and then everyone should be practicing entering it on your calculator. Harlan, you get it written down? Okay, so let's try it on the calculator. You got it written down, Jatavia? Okay, so put it in on your calculator. What'd you get, Dean? I see you entered it. Did you do 13? Oh, you weren't entering this? Okay. King, did you get it? Well, let's do it together. You ready? 13 times 9 times 49 sine button. The fraction bar tells us to divide, so we're dividing by 2 and equals. What'd you get, King? 44.1. So I think we're rounding to the hundredths point. So it's going to be 44.1 watt. What comes after the 1, King? 5. So remember, 1 is the 10th place, 5 is the hundredths. What comes after the 5? Is it 10th or hundredths place we're rounding to? Oh, so we need one more. Okay, so it's 1, 5. What's the number to the right of the 5, King? 0? Okay, yep, so that's how we round it down to 5. So now we know it's meters. This is meters squared. On your assignment, they're not making you select meters or meters squared or meters cubed, but on the test they might. They did the last test, right? Area is always meters squared. Length is always just meters, right? It's one dimension. It's just length. Area is 2 different lengths, the length of the base and the length of the height. That's why it's an exponent of 3. They throw volume in there for you to see if you know the difference. Volume has an exponent of 3 on the unit of measure. Why is that? Because one base times width times height. 3 different lengths, right? So how many lengths are you multiplying to get the answer? That's maybe how you can remember it. You're not multiplying anything to get a length. That's just the unit of measure. All right, here we go. So we're going to pick which side we're going to use as our base. And I actually picked it already. We could pick 9. We could pick 15. Either one. It's not a right triangle. That's a 149-degree angle right there. I picked 15 to be our base. So now we need to draw the altitude. So we need to look at the angle across from this side and draw a line perpendicular, or what would be perpendicular if we extend this side. So we start at the base and draw our dotted line out this way, come up to that vertex at the cross from it, and draw our line down to a 90-degree angle. So now we have the hypotenuse, right? It's 9 inches. And what we need is this side, because this is going to be one of the legs. This is a leg, and this is a leg. Remember, the legs of the right triangle are the base and the height. This is not, if this is part of the base, it can't be the height, right? So this is going to be our height. So let's go ahead and label that as our H. Now, we need to use a trig ratio to find that height. So the first thing we need to do is find out what is this acute angle here? What does that angle measure? What do you think? Miles? (31 degrees, right? 31 plus 145 is 180. That is a linear pair. They are supplementary. Add them together, they equal 180. All right, so now we have a 31-degree angle, acute angle. We have a hypotenuse, and we need to know, is this side the opposite side or the adjacent side from that angle? Is this the opposite side or adjacent side, Maya? Very good. Opposite. Oh, I put the H there already. Let me make that opposite. All right, so now we can use a trig ratio. What trig ratio are we going to use? What trig ratio are we going to use, Amaya? Very good. Sine of the 31-degree angle. What's it going to be equal to? Ibrielle, what's it going to be equal to? What's that ratio going to be? What are we going to put in the calculator? What are we going to run in a fraction, rather?
9 times 31.
Are we going to use sine, cosine, or tangent? Oh, sine. You already said that. Okay. Yeah, so we're going to use sine 31. It's going to be equal to what?
4.6.
Well, what are we going to put in the numerator of our fraction? Let's write our equation first. H, very good. And then the hypotenuse is what? Harlan? The hypotenuse? We labeled it.
Oh, right.
So it's H divided by 9. That's our ratio. Multiply both sides by 9. We're going to isolate our H. We're not going to round it. We're going to leave it as 9 times the sine of 31 degrees. That's our base. We decided that was going to be our base. We already said that. And so now we're going to plug into our formula. What am I going to put in the numerator? Devanshi?
15 times 9 times 5, 31.
Perfect. And the denominator over 2, right? Divided by 2. So now, everybody is writing that down. Everybody's picking up their calculator and seeing if we can all get the same thing. And we are rounding to the 100th place, the second place from the right of the decimal point. Morgan, will you sit up for me? I know you're not thinking about it. I do want you to sit up. What'd you get, Vivian? What'd you get, Xavier? What'd you get, Daria? Or something? Okay, anybody get something different? That's the correct answer. And it's inches squared. Any questions so far? What do you think about it? Okay? Are y'all caught up with me? Oh, poo. No way. All right. We could pick 9 or we could pick 6. For me, the way I see things, 9 is going to be the base for me. And then I can draw the altitude from here to that side. So this is our base, and that's going to make this our height. So if you turn that around, so for the base, that's pretty easy for me to turn around in my mind's eye. For me, I always think of the base as the side that something is sitting on, right? So this one is a little bit easier to me to see than those obtuse triangles that aren't what I would consider sitting on a horizontal line, right? I can imagine if this was turned around and sitting here. It makes sense to me that this imaginary line represents how tall that triangle is. It's harder on these others, I feel like. But even this one, I can kind of imagine this is a flat surface. So this is the bottom. And if I wanted to know the height, it can't be the length of one of the sides because remember we're talking about measuring just the height of the ceiling. You got to go straight up, right? It's going to be perpendicular to the ceiling from wherever you're measuring. Otherwise, it's going to be longer than it's supposed. The measurement's going to be longer than the actual length or distance. Okay. So we don't have to find our acute angle. We already have it. We've got a right triangle here. What is 6? Is it opposite, adjacent side, leg, or opposite leg? Tori? So we picked this as a base, but when our trig ratio, we're not using that one, right? So we're using this right triangle that we've created. So is 6 the opposite of this angle, the adjacent side or leg to this angle, or the hypotenuse, Tori? Good. It's the hypotenuse. It's the side across from the right angle. So our height, is that the opposite leg or the adjacent leg to our acute angle? King? This is our, okay, so H. This is the distance we need, right? So this is going to be our variable, H, for our height. In relation to this angle, is this side the opposite leg or the adjacent leg?
Adjacent.
So remember how you find it. Find the opposite, and the other one's always the adjacent, right? So the opposite is always straight across from the angle. So that one's the opposite, okay, buddy? That's the opposite. We need to know if it's opposite or adjacent because that's how we know which ratio we're using, right? So I went ahead and wrote SOHCAHTOA on the board. I think we've been using this one a lot. So which ratio we're going to use? Sine, cosine, or tangent? Charlie? So we don't want to guess. We're going to use our rules, right? SOHCAHTOA. So you're right, it is sine. OH and SO for opposite over hypotenuse. So we're going to use sine. The sine of that 42-degree angle is equal to what fraction? Darren, can you tell me what fraction I'm going to write there? So we're using sine, right? So we're using the SO part of our memory tool. What's the O stand for? What's the H stand for? Hypotenuse. Now I know we have an H here, and it's a little bit confusing because that's the height of our triangle. But the opposite and the hypotenuse. So the opposite is going to be H, that's going to be in the top. And then the 6 is the hypotenuse, that is in the bottom of our fraction. Mrs. Zimmerman. Steve? Sure. Bye-bye. Your assignment is in Alex Jatavia. I can see that you know you're checking out, so go ahead and get down. Don't forget to put your calculator away, please. All right, how are we getting the H by itself, Elizabeth, times multiply by 6 on both sides. Once again, we're not rounding, so we're isolating our 8. Mrs. Zimmerman. Do I have Lambda Rogers' period? I think he's 6 periods. All right, bye. Okay, so that's our height. Our base is 9. B9, H6 times sine of 42. B is 9. H6 times the sine of 42 divided by 2. Super common mistake, do all this work and forget to divide by 2, as your teacher did when I created this presentation yesterday. So my second period kids, they always help me find this kind of mistake. So I forgot to divide by 2. Super common. That's why we always want to do everything twice, go back through, make sure we haven't forgotten anything. Our calculator makes things quick, but it doesn't double check those kind of things, right? So the area of this triangle is 18.07 or 18 and 7/100 square feet, or feet squared. You can say it either way. Any questions? Think you can handle it? A lot of the same stuff. A little new stuff as far as using our altitude, but the altitude in specifically is not new either. But you see how this goes. Everything from that you've learned from a while back, eventually we pull back in. So just when you think you're rid of something, you are not. We have just a few minutes. Let's not scan and submit our notes right now. Let's go ahead and start our homework, and you can scan and submit your notes later. That way we'll have a few minutes to get started on our assignment in class in case you have a question.